Hey everyone, today we're going to talk about something that I guarantee every single person working with data has seen, that sudden, weird spike on a chart. You know the one. What do you do with it? Well, we're going to look at a much smarter way to turn all that noise into clear, intelligent decisions.
Right, so you're staring at your screen and you see that jump. The first question that hits you is, what is this? Is it a real event, like a product going viral or a disease outbreak? Or is it just a glitch, a sensor that went haywire? The answer to that question can change absolutely everything. And, the stakes here are really, really high. If you think a real signal is just a glitch and you delete it, you've just thrown away incredibly valuable information. On the flip side, if you keep a false alarm, you end up training your models on junk data. Either way you slice it, getting it wrong is expensive.
So, the big question is, how can we tell the difference reliably? This is exactly why we need a better, smarter way to sort through these confusing little moments in our data.
And that new approach is something called Agentic Decision Intelligence. Now, this isn't just about finding weird things in the data. It's about the AI actually reasoning about them and then deciding what to do next. It really shifts the whole game from simple detection to intelligent action. But to really get why this new method is so cool, we first need to talk about why the old ways of doing things just aren't cutting it anymore, especially with the kind of complex, fast-moving data we have today.
I love this analogy. Think about it. Traditional methods, the ones that use simple thresholds like z-scores, they're like a super sensitive smoke alarm. It goes off for everything. Burnt toast, a little steam from the shower, an actual fire. It just screams at you all the time. You get a ton of alerts, but there's no context. It's just noise.
This comparison table really lays it all out. We're making a huge leap from static, rigid rules to a system that uses contextual reasoning. Instead of a person having to look at every single alert and make a call, we've got an agent that can learn and act on its own. It's a massive shift in how we handle data.
So if those old alarms are just way too noisy, what's the solution? Well, it's time to meet the AI agent. This is a system that's designed not just to point out problems, but to intelligently figure out what to do about them.
So what exactly is Agentic Decision Intelligence? It's not just another system that sends you emails all day. It's an AI that spots an issue, thinks about the context around it, and then, and this is the most important part, decides on the right action to take. It turns a raw alert into a complete, intelligent decision. And the agent follows this really clear three-step logic. It's pretty simple. First, it detects something weird. Second, it classifies how serious it is. Is this a tiny blip or a 5-alarm fire? And third, it acts. It takes a safe, autonomous action. Let's see what those actions actually are.
And this is where the safety really comes in. The agent can only do one of three things. It can fix a minor glitch, it can decide to keep what it thinks is a real signal, or, and this is key, if something is too big or it's not sure, it just flags it for a human to look at. No crazy, uncontrolled actions here. It's all very constrained.
Okay, so the theory is great, but let's see how this thing actually performs in the real world. The researchers pointed this AI agent at one of the messiest, most important data sets you can imagine, daily COVID-19 case counts. So here's the basic setup. They pulled live data from an API. To spot anomalies, they used pretty standard statistical stuff, looking for big spikes or really fast growth. Then they'd classify each one as minor, a warning, or critical, all based on how much it grew compared to the last week's average. Sounds pretty straightforward, right?
So let's actually look at a few real-world examples and see how this agent did when the pressure was on.
Okay, first up, a minor anomaly. The agent sees a little localized spike. It classifies it as minor, and its decision is to fix it. So what does it do? It automatically smooths out that data point using a rolling average. This is awesome for cleaning up little reporting errors without a person ever having to get involved.
Now, check out this next one. The agent sees a huge spike in cases and right away classifies it as critical. And what's its decision? It knows better than to touch this. This could be a real outbreak, so it makes the safest possible choice. Flag for review. This is what prevents it from accidentally erasing a vital public health signal. But the system isn't perfect, and that's just as important to understand. In this case, it found an anomaly it called a warning, but instead of flagging it, it decided to autocorrect it. Now, in a lot of situations, a warning level event is something a human would definitely want to keep an eye on, not just erase. This really shows why human oversight is still absolutely essential. So when you put this all together, what does it really mean? It means we're seeing a huge shift. We're moving away from systems that just detect problems to building systems that can make smart decisions about them. And this quote from the author, Mathura Raut, just nails it. The goal isn't to get more alerts. The goal is a controlled, decision-driven system that can work safely right alongside human experts. So, what are the big things to remember here? First, use your simple stats to find the weird stuff, but let an AI agent be the one to decide what to do. Second, go ahead and autocorrect the minor noise, but never, ever let it autocorrect a critical signal. And finally, remember the whole point is to build a decision-making system, not just another alert system. And of course, this is not something you'd use where an automated action could be irreversible. This whole thing shows so much potential way beyond just public health data. And it leaves us with a really powerful question. Where else should we be using these automated decision makers? I mean, think about it. Financial trading, sales forecasting, supply chain management. What other noisy, messy datasets are just sitting there, waiting for a smart agent to finally make sense of them all? That's definitely something to think about.